Ms Himabindhu, Assistant Professor in IARE College. So today in this video, I would like to explain the questions on context-free grammar. So some of the questions we have to take it from the question bank, and we are going to discuss how to solve those problems with the context-free grammars. So before going to solving the context-free grammar problem, so what is meant by context-free grammar? So in the Chomsky hierarchy, where is the position of this grammar? And we need to discuss about the context-free grammar. So coming to the Chomsky hierarchy, so we have the grammars of four types. So one is a regular grammar. So regular grammars are represented with the type 3. So this is the type 3. Type 3 grammars, we can also name it as a type 3 grammars. These are RE, RG represent a regular grammar, and which is and also having the context free grammar. So this is a type 2 grammar. So this is the type 2 grammar. So where we are, what we are going to discuss about the grammars is context-free grammar. So the context-free grammars, it is also having the subset of regular grammar. So we can construct the grammar for the regular grammars are also for the context-free grammar. So here these are the two types of grammars in the Chomsky hierarchy, and two more grammars are there. So what are those in the sense? Context sensitive grammar and unrestricted grammar. So unrestricted grammar. So these are all the, so this one is a type 1 grammar, and this is the type 0 grammar. So these are all the types of grammars in the finite automata. So here in this one we are going to discuss about the context free grammar. So which is a type 2 grammar. So in this one, how we are going to define the grammar and what are the tuple notation we need to discuss about the context free grammar, we will discuss. So coming to the general notation of every grammar, so G is represented with the 4 tuple notation. In this one, so V is nothing but a non-terminal. So V is nothing but non-terminal. So in the transition diagram, we require the state. So in that, so finite number of states are required. Like that here in the grammar, so non-terminals are the set of states. We can represent it as a states. And T is nothing but the terminal. So the input strings. So alphabets, those are all named as a terminals. And P is nothing but the production. So productions are nothing but it is a combination of both V and T. So we can also write like V union T. So we can combine it together to form a production rules. And S is the status symbol. So these are the basic grammar definition for the context-free grammar. So in this one, the most important thing is the production. So in this production, so how to define the production? So how for the context-free grammar? So what are the limitations? We have 4 types of grammars here. So every grammar is different from one grammar. So how to differentiate those grammars here in the sense? We have the production rule. So here this is the, if it is a supposed production rule which is going to start with the S letter, and we can say right hand side it is a combination of V union T. So non-terminal union terminal. So either it can be a single terminal is there, and also it is having the combination of two one non-terminal and terminal. So like this, the right hand side. So right hand side we can write any number of productions. So like V union T. So but coming to the left hand side path, so we have only a single non-terminal value is represented for each and every production. So this is the thing we need to observe in the context-free grammar. So this context-free grammar, it is having the left-hand side only a single non-terminal value, and right-hand side it is a combination of both terminal and non-terminal, or only a single terminal is also accepted. So this is about the context-free grammar, basic thing we need to understand. So left hand side, every time for every production we will represent it with a single non-terminal value. Coming to the other language, other grammars, so here the grammars which have type 2, type 1 and type 0, those are unrestricted. So those are unrestricted in the sense, so type 1 is having the left hand side no limitations when compared with the context free grammar. So like that the types of grammars are different from one grammar to another grammar. So here this is about the context free grammar. So G is nothing but the grammar which consists of a set of production rules. It is also used to generate the strings of language. So why we are going to use the grammar in the sense to represent the strings of a language, we can represent with the grammar. And T is nothing but a finite set of terminal symbols, so which are represented with the lowercase letters. So T are nothing but the terminals, the input values which we are going to represent with the lowercase. And V is nothing but the final state. So finite set of non-terminal symbols. It is denoted by the capital letters. So V is nothing but the capital letters. Those are all represented with the capital letters. And P is the nothing but a set of production rules which is used to replace the non-terminal symbols, the left hand side of the production. So just now we discussed the production rules which have the left hand side and right hand side. So right hand side it is a combination of V union T. And left hand side we will represent, for the CFG we will represent with a single non-terminal value. And S is the stat symbol. So S is the stat symbol which is used to derive a string. So here the strings which we are going to derive the strings from the given language, we have to start with the S symbol or stat symbol only. So these are the basic definition for the context free grammar. And coming to the conversion, so here we have given some of the examples we have taken from the question bank. So here different examples are there. So in that one, first one is about the context free grammar. So it is having the 4 tuple for the given language. So we need to find the grammar for these 2 languages. So this represents context free language to context free grammar we need to convert. So here the language we have input is the language context free language, and we need to convert it to a context free grammar. So grammar requires a 4 tuple notation VTPS. So here we need to write in the grammar representation for the given languages. Coming to the first one, so here the first one is all the strings having at least 2 A's. So all the strings are having at least 2 A's, and all about the values are A, comma B, whole stop. So what it says that, so it's maybe a combination of A, B. So the string either it contains A or B, and which can starts with A or B. So there is no possibility of only starts with A or starts with B or ends with A and ends with B. So what they are saying, all the strings having at least 2 A's. So at least 2 A's in the sense, in that string the minimum number of A's should be 2. So here how to represent those into a grammar representation. So first thing what we have to do, we need to start with the S. So let me write first language for this strings for this language. At least 2 A's in the sense we can write 2 A's is also possible. And in between these 2 A's we can write so A plus B whole star. So what this says, A plus B whole star in the sense it is either it can be starts with A or B or multiple A's or B's. And A is must and should, and in between this A plus B is also. So here what they are saying, the language it contains double A's at least. So 2 A's are must and should, so that's why. So we, more than 2 also is acceptable here. So that's why in these combinations we will get more A's. So that at least 2 A's are satisfied here. In between these 2 A's we are writing like this. So either it can be having multiple A's or B's or A B combinations, and here also. So these two are must and should. At least two A's are required here. So we are satisfying that condition. And this is how we are going to return the language. For this language, we need to write the grammar. So how to write? We have to initiate the. So let me write the production rules directly. So S, we need to start with the S. So by seeing this one, we can say that it is a combination of A. So A must and should in between two days A plus B whole star is required. So here how can I write this one? A. And this A plus B whole star I am writing as a one more non-terminal A and A. So for this one A plus B whole star I will write. So A tends to, so either it can starts with A or B, A or epsilon. So epsilon is also accepted. Why? Because if we write epsilon here, entire thing epsilon, we will get the A values. So that this condition is also satisfied. So like this, we need to write the production rules for the given language. And first we have written the production rules, and S already we have. And T is nothing but, those are T is nothing but the values A comma B, and V is nothing but S comma A. So these are all the grammar for the given language. So all the strings having at least two A's, in the sense we need to write the production rules like this. So this is the first one, and second one, we need to all possible strings not containing triple B's. So triple B's in the sense, so here the language what we don't triple B's should not be there in the language. So what is this? The triple B's are not allowed. So what double B? So by removing this condition, double B's are allowed and single B's are allowed, and it's a combination of B is allowed, and B is also allowed. So what this saying, these type of languages, and empty string is also allowed, that is nothing but epsilon. So these are all the different types of possibilities for this given language. So we will write the name of every possibility in the grammar, and we'll write the production rule. So triple B is not accepted here. So double B is accepted and single B is also accepted, and it is a combination of B is also accepted and B is also accepted. Empty string also accepted. So these are all together. We will write one equation as a production rule. So here, so S starts with, so epsilon will write as a epsilon not A, B and BB, and A, B, EB, A, BB. So triple B is not accepted, so we will stop it here. And in case of this A plus B, so B is there, we need to stop there. So B is not included here. So here and so on we will write. And here for the same thing, how to represent in the production rule. So S tends to, so epsilon is accepted and B is accepted and BB is accepted, and the string. So this, from this here, the X is a string. So X is a string. Then XA is accepted. So X is a string. XAB is accepted. And XA is a string. XABB is accepted. So till now we will all accept all those three things. So these three things we will name it as here in the grammar. So X, instead of this X, it is a combination of AB. So we will write together S, we will write A. And instead of this X, yes, AB. And instead of this X, yes, A, B. So if we write all this production rule, so we'll write together one equation here. So first what we have to do, we need to understand the language, then we need to remove all the possibilities of triple B's, then we need to write the equation. So this is how we are going to write the production rules for the given language, context free language. So coming to the altogether definition of grammar. So Z is equal to, so production rule is already there, S is there, and T is nothing but it's a combination of A comma B, and S already there, and V is nothing but S, only S. So why? Because we are just having only one equation, so that we will write together like this. So, and these are the pre-production is nothing but only one value is there. So this is about the all the possibilities of strings not containing triple B's. So these are the two examples of the language. The input is a language and we need to convert it to a grammar, context free grammar. So this is one type of example. And here we have one more important thing, leftmost derivation and rightmost derivation. So the input is the grammar they are giving, and we need to convert it to a, we need to derive the string from that grammar. So whether we have the two types of derivations, one is the leftmost derivation and rightmost derivation. So further we have to take one string and we need to derive that string from the given grammar. How to derive we will see. So they are asking for the leftmost derivation and the rightmost derivation. Rightmost derivation. So here we'll deriving what is the input string. We need to derive this string. So to derive any string from the language, we need to start with the we need to check for the string starting and ending. So here we have the value A is the starting. So here in this one, we need to start with the S only. So S production rule we need to start. So production rule S tends to, we need to start. So we will take leftmost derivation, we will start first. So leftmost derivation. So S tends to A. So we have the string A is there. So initially what is the string contains, we need to search for that terminal so that the derivation is become easy. So here A is there in the starting state S. So A with the combination of A, is there any equation or not, we need to check. So yes, we have this equation. So we will substitute the value of B. And here after this one we require one more A here. So here in the leftmost derivation we need to move from the left to right direction. So we move in the sense we need to substitute the values of capital letters. So those capital letters, what we are going to, we have to move from left end to right end. That is nothing but leftmost derivation. So here we have only terminal is there, A is there, terminal, and next one non-terminal we need to substitute. So here only one B is there, so that we need to change, we need to substitute the B value. So what we have to do to get the one more A? So if you substitute B with this value, B with this A, B, B, we will get one more A. So B tends to A, B, B is if you substitute. So A, BB I am going to. So leftmost derivation in the sense we need to move, we need to start from the left hand side. Whatever their non-terminals are there, we need to substitute those non-terminals from the left hand side. And here we require one more A. So one more A, how to derive this one more A? We will substitute A, B, B. We will get triple A. So triple A, B, B, and for this one we will writing B. So here this is the thing, and let me write the values what we have substituted. A tends to A, B, B, and B tends to A, B, B. Again we substituted 3 times, and now we need B, double B are required. So if you substitute this B, again we will get, if you substitute the value of A, B, B, we will get A, one more A. So we need only B. So how to define this VB? So here I will substitute AA. So instead of B, this leftmost B, I will write a B, and also 2 times I will repeat B, B, and this B is left here. And next one, so to get one more, we finished till now. So here A is required here. So for the capital B, if you substitute A, B, B, A, B, so A, B, B. So again we got the value of A. So one more time, and here leftmost derivation, this B has to be substituted. So here what we have written, B tends to A, B, B. A, B, B, A, and B tends to what we require, again B require, so that B tends to B I will substitute. So B tends to B, and this B is replaced and capital B is there. And again we require double B A. So how to double B A is required here, so that A, B, B, A, B. If you substitute B tends to B S, so B S, so B double B is happened, and one more B A is required here. So for the B A, we need to substitute the S with the B A. Then we will get the what the string we have to derive. A, B, B, S tends to B A. So and again A, triple A, B, B, A, B, triple B, and A tends to A. So here we derived the string leftmost derivation. So derive the string from the leftmost derivation. So like this, we need to derive the string for the string from the rightmost derivation. So how to derive the same string from the rightmost derivation, we will check. Rightmost derivation. So first thing, so whatever this, we need to start with the capital A only, and we need to start with the capital first letter, and we need to start from the start state only. And here A is there, so to derive the A from the equation, we need to take this equation A, B, and here we need to substitute A with B with the A, B, B value. So here B tends to A, B, B. And here if you observe, it is a rightmost derivation. So here we have the two B's are there. So in this one we need to start from the right end. So right end, whatever non-terminals are there, we need to substitute. So A, B, and this B. So for this one we require the BA. So that we need to substitute the value with the A, B, B. So B tends to A, B, B. So let me try. So here B, A, and here if you have triple B is required. So triple B, A, if you derive, so A is already there. So BB is there, triple B. How to define the triple B? BA. So if you substitute the value B directly, and we require to substitute this B value. So B instead of this B, if you write BA, BS, so BS, so again A, B, B, S tends to, so S tends to here, we require S tends to BA. So BA if I substitute, so S tends to A, B, A, B, B, A. Now here if I substitute A with the small a, so BBA is happened. So and here one more B is there, and we need to substitute this B with the, again we need AB value. So AB value is required here, so that we will substitute directly this A with A, B, A. So directly B, B, A if I substitute. And here one more B is there. So B tends to, so here B tends to B and A, B tends to A, B, B. If I take A, B, B, so A, B, B, A, B, B, A, B, B. So this B is, we need to substitute. So B, B, A. And here, and after this one, we got this derivation. So A, triple B, A is required. And we need to BB is there. So that, so just directly we will substitute the value of B with small b's. And we just derived the string. So B tends to B. So this is how we are going to derive the string from the either leftmost or rightmost derivation. So this is the context-free grammar derivation, leftmost derivation and rightmost derivation for the given context-free grammar. And derivation tree. So we can also derive the same thing with the derivation. So let me derive this one. So first leftmost derivation tree I will write S. S tends to A, capital B, and B tends to. So just we need to substitute what we have substituted. Instead of this one, we will write. So instead of this B, what we have written A, B, B. So next B tends to, again first B is there and second B, and again B we have. So A, B, B. Yes, this one B is there. So later we will write. After this one, we just substituted this B, two B's with the small B's, and now again we need to take this B and this A, B, B, and here A, triple A, double B, A is there, and here again we require 3 B's. So 3 B's require, in the sense we need to substitute the value with the, so here after this one B, so B we need to replace with the B, and BB A is required. So here instead of this B we will write BS. So BS, so we have, so S tends to B, A, and A tends to A. So if you observe this derivation tree, we will get the string derived. So here triple A, B, B, A, B, B, triple A, B. So like this we need to derive. After derivation we can also write the derivation tree. So either it is a leftmost derivation or rightmost derivation. After deriving the string from the given grammar, we can directly write the derivation tree also. This is how we are going to construct the derivation tree for the given context-free grammar. And this is one example. And here we have the Chomsky normal form. So here what we have to do, so this is the normal form. So those normal forms we need to represent in a standardized way. So to represent the grammar in the normalization, we have the 2 steps. So one is the minimization, and next comes the Chomsky normal form. So here we need to minimize the grammar first. For minimization, minimize the grammar. So in this one we need to eliminate, so we need to remove the useless symbols, and the second one we need to remove the epsilon production, and we need to remove the unit production. So these are all the 3 steps we need to perform for the minimization of grammar. So here and after this we need to convert it to a Chomsky normal form standardization. So the Chomsky normal form rules are, So here rules are nothing but the left hand side, it is a combination of two non-terminals, or single terminal is also accepted. So like unit product S tends to A, capital A, S tends to epsilon, and useless symbols S tends to D is not deriving the string. So these kind of all the things are going to be removed from the grammar. So this is the thing only we need to observe for the normal Chomsky normal form. So here they have given the context-free grammar. This grammar should be converted into a Chomsky normal form. So in this one, if you observe, we need to minimize the grammar. First step is we need to minimize the grammar, and then we need to convert like this equations. So here to remove the minimize the grammar, we have three steps. One is a useless symbol removal, a unit epsilon production removal, and unit production removal. So here we have useless symbols or not there or not, we need to check. So see A small a capital E. Let's start from the start state. So here this equation is going to be derived or not, we need to check. So here in this one we have the two values, AA is there. So capital A is there. So capital A, is there any having the terminals or not? So yes, it is having the terminals, so that we can derive this equation. So how to derive? S tends to A capital A instead of this A capital small 2S and A 2S. So we derived the string from this equation. So this equation going to be there in the grammar. And coming to the CA. So C, already we have the A terminal. So A tends to AA is there. So that no need to check A. And what about C? So C tends to any terminal is there or not. So C tends to CA. So loop is there. So how many times you write the equation of C, we will get the C. But we don't have the terminal value. So we can't derive the equation from the C. So C don't have any terminal. So here it is having the D. So this D is also not deriving the terminal. So these two equations are eliminated from the grammar. Why? Because so these two are not derived from the start state, and whether if it starts from the start state also, but the derivation is not possible with this equation. So here that's why we have to remove this CA also. Whatever there with the combination of these two non-terminals, we need to remove those things. And here in this equation is there, in this equation and this one, only three things. So, and let me check for BAB. So BAB. So B, it tends to this terminal is there. So this terminal is, this equation is also be accepted. Why? Because BB A BB is the string we are going to derive from this equation. And here B is already terminal. So this equation is there. And this terminal is also there. And this one, and this one, this one, this one. So these are all the grammars after minimization. Let me write after minimization what are the grammar should be involved in this normal form. So A is deriving, so that I am keeping, and B is there, and A tends to AA, BA, and AA, and so B tends to B, capital B, BAB, and BBAS. So these are the equations after performing the minimization step. So in this one, we just removed, we have only useless symbols, and here we have the unit production, but if we are deleting all the things, so that this unit production is also removed from this equation. So this is the thing. And next step what we have to do, we need to convert it to a normal form. So normal form equation, it is having the right hand side, it is a combination of two non-terminals. So here there are three things are there, it's a combination of terminal and non-terminal, and here also three things. So we need to convert it to a two non-terminal values. So So if you take S tends to, so if you substitute the A value with the one more capital letter, so A tends to, X tends to A. I will take X value. So A X A and B X B. And here also we will write A tends to. So we need to if in case in this equation if we have any terminal value, we need not to substitute. Why? Because it is again a unit production, comes under the unit production. So terminal is there, it's already there in the rules of CNF, so that we are not changing the terminal value. So in this grammar we don't have a single terminal, so that all terminal should be changed here. And here A tends to X A, B X and X X, and also B tends to, so B is there instead of this B, so we will write Y tends to B. So Y B and Y A B and Y Y and X S. So in this one, if you observe, we already have some equations in the CNF. We need not to change those equations. What are those? So XS is a two non-terminals and XS is also two non-terminals. YY is also a two non-terminals, and here YB is also two non-terminals. So remaining we need to change. So in this one, S tends to AXA. So if you write the two equations, two non-terminals together in a one terminal value, so here Z tends to XA I will take. So AZ and B tends Z, D tends to XB. So D, and here also we have X tends to A and Y tends to B. And here I need to write A tends to XB is, so XB is D value. So X, D, X. And XX we no need to change. And B also no need to change. And here, so YB is there, and here YAB is there. If you write one more value, C tends to AB. So here Y, C, YY, YXS. And here only this thing is left here. And here I will write the after this one. So A tends to, so dx we will write together one as a E tends to dx. So xe, xx. So all remaining all are in the equation. So in the CNF. So like this we need to change, we need to convert the given grammar into a Chomsky normal form. So this is one type of question. And one more, given we need to convert the grammar, context free grammar into a Grayback normal form. So we have two types of normal forms. One is a CNF, a Chomsky normal form, and the second one is the Grayback normal form. So first one we already discussed, CNF. We have the rules like for CNF we need to write the grammar in S tends to two non-terminals or single terminal value. So, and coming to the GNF, so GNF, so for doing the procedure for converting into a GFG into a GNF, we need to first CNF, we need to convert the grammar into a CNF, then we need to convert it to a GNF. So, what are the rules of GNF? So like this here two non-terminals are there, like this here also it's a terminal, it is a combination of n number of non-terminals and also with the terminal of single terminal. So not exactly A, these are all the examples, just examples of rules. So how to represent the production. So these are the rules we need to follow. And here first step, for convert the GNF into convert the grammar into a GNF, we require the grammar should be in CNF. So this already have this grammar, the given grammar is already in the CNF. How to check whether it is a CNF or not? So if you observe A1, A2, A3, so these are the two non-terminals. So non-terminal, non-terminal, and this is also non-terminal and non-terminal, and this is non-terminal and non-terminal. So all the grammar has having the two non-terminals and also single terminal. So by seeing this one, we can say that it is a CNF grammar. So, and for converting into a GNF, we require the equations. So we have the values here A1 and A2. Let me write A1 tends to A2, A3. So here left hand side, I will take the values of this two values. So I, J. So we have the conditions. If I is less than or equal to, we need to change the production. So change the production value. Production value. And if I less than or equal to J, no need to change. No need to change. So for this equation will apply the two all the grammar in the every production rule. So first we will take A1 tends to A2, A3. So I 1 greater 1 less than 2. So this condition is satisfied, so that I am not changing anything. Coming to the second equation, this A3 and A1 and B terminal. So this is also I less than 1 less than 3. So this is also 2 less than 3. So this is also satisfied. No need to change now for now. And if you take A3, so A3, A1, A2 is there. So here 3, 1 is there. So here I greater than or equal to greater than J. So that 3 greater than 1. So that we need to change the equation. How to change in the sense? So we'll take this A3. A3 tends to A2. From here I will write. So here, so A3 tends to. So instead of this A1, if you substitute the equation of this A1 value, we will get A2, A3 and A2 dash A. So we have the value A2, A3, A2. So here again we need to check I 3 less than 3 greater than 2. So that again we need to change. So A3 tends to, so A2 we need to substitute. So what is the value of A2 here? This one. So A3, A1 slash B, altogether A3, A2 and E. So here we need to write, so A3, A1, A3, A2 and B, A3, A2, A. So if you check, this is the 3 and this is 3. So I 3 equal to 3. So what it says, it is a left recursion. Left recursion. So we need to remove this left recursion. So how to remove this left recursion? We have an equation. A tends to A alpha. So these A values are, these two things are same. So A alpha and beta. So if the equation is like this, we need to introduce a new variable called Z. So Z and Z tends to beta Z epsilon, and here A tends to, and again we need to write this equation. So here alpha Z and epsilon, and here A tends to, again we need to write this equation in this form. Instead of this equation, so we need to write like this. So here a beta Z. So this is the equation we need to write. So here what are the values of alpha, beta and Z? So here coming to the alpha value, so we are only taking A3 as a part, remaining all thing is a, so remaining all is a alpha. So alpha is here, alpha is equal to A1, A3, A2. So like this we need to substitute, and remaining is beta. So beta is equal to B, A3, A2, A. So like this we, and Z we need to introduce. So here A3 is equal to, so instead of this beta, so beta is nothing but B, A3, A2, A and beta Z. So what is the Z? So Z tends to alpha. So alpha is equal to A1, A3, A2 and Z. So Z we need to introduce, and epsilon. So epsilon, and here we need to write this equation A, Z. So A with the Z value, what is the Z? A1, A3, A2, Z, epsilon. So after substituting this one, we will get A3 value as a, so A3, A, B2, A, A1, A3, A2, Z and A. So A3 we have, if you observe the value of A3, we got the equations like it is a combination of terminal and non-terminal. So terminals followed by the n number of non-terminals, so that it is already in G and F. And this one also already in G and F, and this single terminal is also already in G and F. And next all A3 is fully G and F, so no need to change. And one more thing, we need to substitute the value of Z also. Why? Because the Z value is not following the G and F rule. So we need to substitute the A1 value. So before going to convert the A1 value, so let me check, let me write all the grammar together and then we will write. So here A1 tends to, so A1 is there, and what is the value of A2? So if you substitute the value A2 tends to B, we will write B A3. So B A3 is G and F. So and A2 tends to A3. So instead of this A3, we will write this equation. So B A3 A2 and A1 A3 A2 Z and Z and A. So this is the entire A3, and we have the value of A1 and B. So if you substitute all the values, so A3, A3, A, A1, A3, A2, Z, A1. Here A1 I need to introduce, and here A1 and B. So if you observe, A1 is already in GNF, and this A2 also in GNF. Here this is the A2. So this is already in GNF, and this one is also in GNF, and A3 is there. And here Z is there, so we need to check. So A1 is there. So instead of this A1, we just directly B A3 I will substitute, and with the equation A3, A2, Z, and here epsilon is also there, and here B A3. So here B A3, A3, A2, Z. So B A3. So like this we can convert the all together the given grammar into a. So all together we so G and F. So for this grammar into a G and F. So here we need to write the grammar for every G and F grammar. We can convert it to a G and F. So here we need to, first step in G and F, we need to minimize the grammar, and then we need to convert it to a C and F, and then we need to convert it to a according to the G and F rules. So these are the questions we have discussed till now in the context of free grammar. So these are the references. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.